In a world where technology is gradually taking over, traveling to a distant galaxy might be possible in about millions of years. But what if it's possible to travel into space within the blink of an eye, through some sort of shortcut? Wild imagination, right? Well, never say never, because wormholes might just have the ability to make it happen. While scientists and science freaks are optimistic about the tantalizing potentials wormholes might have, regular people like me can't help but wonder how this can even be possible. Rather than arguing about whether or not they hold potential for real-world science, let's dive into the mysteries of wormholes and see how exactly they propose breaking space-time. Think of wormholes as magical tunnels that connect the universe and let you travel far distances within a very short time. It acts as a bridge between distant points in space-time. Scientists have predicted that the bridge is shorter than the distance between the two given points, allowing for faster travel. Although they believe these tunnels might exist in space, they're yet to find one in real life. Therefore, the whole story about wormholes is still theoretical. Some even think they're unstable, and making them would be nearly impossible. But then a certain mathematician, Matt Visser, said that if the early universe created cosmic strings with negative mass, we may have countless wormholes scattered across space-time. To make it more interesting, physicists Kip Thorne and Frank Tipler also came up with the idea of crafting artificial wormholes engineered by advanced technology. More than just shortcuts through space, these theoretical tunnels spark thrilling ideas of time travel and teleportation in us and make us wonder what could be possible if we could leverage these cosmic curiosities. I guess understanding the theory behind wormholes is the best way for people like me, who are neither scientists nor science fiction fans, to go. Wormholes came into theory in 1935 by physicists Albert Einstein and Nathan Rosen. This is why they're also called the Einstein-Rosen Bridge. They simply extended Einstein's general theory of relativity, and their equations suggested that space-time could bend and fold to create shortcuts. Breaking down the theoretical structure of wormholes would help us understand them. So let's do that. Each wormhole has two entrances that you can call mouths. These can exist at any 2 points in space-time. Each also has a throat, which is the tunnel. The throat is responsible for connecting the two mouths and providing the pathway between them. For a wormhole to be useful, matter must be able to pass through it without being destroyed. In other words, it must be traversable. That explains why science fiction writers are particularly interested in traversable wormholes. They bring the hope of faster-than-light travel and even time travel. This also tells us that there are even more than one type of wormhole. Did you know that there are as many wormholes as there are scientists who theorize them? And just like our fingers, wormholes are not equal. They vary in stability. It seems like every scientist named a wormhole after themselves. So we have wormholes like Schwarzschild and quantum. However, some major wormholes are generally accepted by scientists. Traversable wormholes seem to be the most popular and intriguing kind when it comes to science fiction. They theoretically allow us to travel between different regions of space-time. They are believed to be stable and require exotic matter to remain open. Non-traversable wormholes are the exact opposite of traversable. They are unstable and only exist as mathematical constructs. Therefore, they would collapse before anything, even light, can pass through. Even worse, the person or particle passing through it can be destroyed before they get to the other side. Some wormholes also allow matter to travel through them only once. These are called one-way wormholes. This means once you go in, you can't come back unless you have a separate wormhole for your return trip. That sounds hilarious. Black holes are examples of one-way wormholes. Since we have one-way wormholes, it only makes sense to have two-way wormholes as well. These are the types that allow a return trip through the same wormhole. They're also known as round-trip wormholes. Inter-universe wormholes are believed to allow us to connect different universes. Although this sounds interesting, the concept remains highly theoretical. Intra-universe wormholes, on the other hand, are just for traveling within our universe. Obviously, traversable wormholes are the only types that bring a ray of hope. But what if wormholes can't be traversable? The idea of traversable wormholes has captivated scientists and science fiction fans. But in reality, can they work? A wormhole is only traversable if it's stable and open long enough for matter to pass through without being destroyed. This can be possible if there's an exotic matter that has a negative energy and repulsive gravity. It acts as a hindrance to the immense gravitational forces that would have caused the wormhole to collapse. As beautiful as it sounds, creating and managing exotic matter is still purely theoretical. In fact, even if traversable wormholes are mathematically possible, we currently lack the technology necessary for their practical construction and use. So for now, we can only dream about the beautiful concept and hope that our dream comes to pass someday. While we are hoping wormholes become a reality, we shouldn't forget the fact that they might not be the savior we think we just might have found. So let's even say scientists are finally able to find or create a wormhole. Do you think they would come risk-free? While wormholes offer thrilling possibilities, they also come with risks and dangers that make them as dangerous as they are fascinating. According to theoretical models, wormholes could emit intense radiation, especially near their mouths. This radiation poses a serious risk to both the travelers and the environment. If a wormhole connects two regions of space-time that have entirely different conditions, like a high-energy region to a low-energy one, it results in an imbalance that could lead to catastrophic explosions or collapse. Naturally, wormholes are unstable. Even the tiniest energy fluctuation could result in a fatal collapse, especially in the absence of exotic matter to keep them open. Once they collapse, they immediately crush anything inside. You can't predict a wormhole's exit point. It could drop you in distant galaxies, harsh environments, or an environment where survival is impossible. Surprisingly, scientists have not stopped exploring the possibilities of wormholes despite these challenges and risks. That's quite understandable though, especially when there's the possibility of traveling back in time through wormholes. Some of us would really love to travel back in time to make some amendments, but while the idea of using wormholes for time travel is thrilling, it opens us to more questions and confusion. For instance, the grandfather paradox asked what would happen if someone traveled back in time and prevented their own existence. Questions like this, which have remained unanswered, have made time travel through wormholes an exciting but deeply confusing concept. While we're still confused about the whole idea of wormholes, there's also the question of where we might be able to find them. Of course, that's if they exist in the first place. If you ever thought finding wormholes would be like eating your favorite food, then I'm sorry to disappoint you. Even if wormholes exist, they might be hiding in the extreme part of the universe, and finding them won't be as easy as it sounds. According to some theories, wormholes might be hiding in extreme cosmic environments. These are environments with intense gravitational forces, like near black holes or neutron stars. Space-time warps immensely in these regions, which is the perfect condition for the formation of wormholes. However, none have been found so far. Quantum mechanics also suggests that quantum wormholes exist in subatomic levels. At the smallest scales, these microscopic structures, which are smaller than atoms, may pop in and out of existence within the quantum foam. The dark universe is another place we just might be able to find wormholes. As you know, the universe mostly consists of dark matter and energy, and invisible mysterious components that we can't measure directly. This explains why finding them with the trending technology would be almost impossible. In fact, only those who can imagine anything would believe the whole idea. Wormholes are a blend of scientific credibility and unparalleled imagination. They awaken the creativity in us and help us to investigate big concepts like the effects of warping space-time or the risks of interfering with the cosmos. In science fiction, wormholes aren't just theoretical. They're a gateway to imagination itself. Although they remain theoretical in science, their adaptability makes them the best plot device in storytelling. Creating a wormhole might be far beyond our current technological capabilities, but it's not entirely impossible. Humans are generally curious beings, and one of the ways to further pique our curiosity is the formation of wormholes. This way, we get more drive to explore the unknown. While they remain in the realm of theory, their implications stretch our imagination and make us consider possibilities that are far beyond what we currently know about the universe. So, whether they truly exist in nature or they're just science fiction, the simple fact is that they serve as a reminder that the universe is far stranger and more wondrous than we can ever imagine. Maybe if we could truly break into space, wormholes might just be a reality.